Hello, everyone, and welcome to our webinar today. We have Mimaki here with us at Shapeways talking about full color 3D printing. I am Rhonda Geet, Director of Marketing Communications at Shapeways. And before we get started and I introduce our speakers, I would like to do a little housekeeping items. On your right side of your screen, you will see a chat. You can ask all of your questions there. We will try to get to all of them. If we don't, we will follow up in an email with you. There's also going to be poll questions and some handouts. And with that, I would like to introduce our two speakers, Steve Wart and Josh Hope. I'm going to turn it over to them so that they can tell you a little more about themselves. And with that, Steve, I'll let you take over.
Thank you, Rhonda. So I'm Steve Ward, Director of Customer Success here. So essentially, I'm in charge of anything that's related to the customer after purchase. So if you need any help from anything from like material consultations, like learning more about Mimaki and how to print with them, all the way to just like tracking your order, you'd be working with me or a member of my team. Been in the additive manufacturing industry for about 7.5 years. So I have to say every single day, always interested in seeing kind of what new amazing technology that's come out. And specifically, one of them that I'm most interested in learning more about today is Mimaki. So with that, I'll pass you off to Josh.
Thanks, Steve. So my name is Josh Hope. I'm Senior Manager for Digital Imaging and Innovation at Mimaki, which basically means I get to play with the cool stuff before anybody else does, which is a great position. So been in the printing industry for 25 plus years, but since 2017, I've really been focused on the full color 3D products from Mimaki. So I am kind of evangelize about the product, let people know what you can do with it, help them see the possibilities for it. And then we have a great team here at Mimaki, Jaime Martinez, who does a lot of our file prep and things like that. A lot of the models that you're going to see today, he did a lot of the prep and preparation for it. And we're really excited to be able to work with Shapeways because we know that they also have some super talented people and going to be able to output some amazing results with these machines. So from there, I think we're just going to jump in. So I'm controlling the slides. Sorry, folks. So this is I think something.
I was trying to unmute and it was not working. Yes. So before we start, yes, you are controlling the slides, Josh, but we do have a poll question. So if you go to your poll tabs, you should see the question on your screen. If you can take a few moments to fill this out so that we can see what level everyone is.
Oh, this is cool. I like the poll thing. This is exciting. So far, it looks like it's a really good mix of people.
Yeah. I'd like to see more, obviously advanced because, it's hard to design for full color, right? It's not as easy as just designing for a regular 3D file. So it's nice to have a couple advanced users in here too, kind of learning about this technology.
Yeah, and I think that's the really great thing is that, I look back at some of the previous printing technologies like in sheet fed offset printing when we started going to digital to plate and desktop publishing even. Customers really heavily relied on service bureaus to be able to get that output because they were still learning about the technology. The machines were a lot of out of their reach from a budgetary standpoint, and so I see this as being a really similar situation, and that's why we're so excited for Shapeways to be able to really pave the path and take a lot of that learning edge off and say, hey, you design it and let us show you what the output can be. And then those two ends will kind of grow together, right? Awesome. So yeah, it looks like we've got most of the people answered, and again, it looks like a pretty good mix with beginner and advanced being the two highest ones. So that's interesting. All right, so I think we're going to go ahead and jump in here. So just to talk a minute about Mimaki Engineering. So I work for Mimaki USA. We're a subsidiary of Mimaki Engineering. But Mimaki is not necessarily a household name if you don't come from the wide format inkjet or textile inkjet world. But Mimaki's been around since 1975. We've got over 1,900 employees worldwide. They're on the Tokyo Stock Exchange. And you can see we've got locations all around the world. And in the United States, we actually have 6 regional offices throughout the United States. So Mimaki is, like I said, not exactly a household name. It's definitely a name that's been a strong name in the printing industry for a long time. So while Mimaki started off as 2D printers, cutters, flatbed printers, things like that, back in the end of 2017, we announced the Mimaki 3D UJ553. And we sold our very first unit in December of 2017. So this is the flagship model from Mimaki. This is the machine that if you're sending full color models to Shapeways to be printed, this is the device that they're going to be printed on. So we wanted to take a little bit of time to talk about some of the technology behind it. You're going to see some examples of prints that have been done and talk about what markets are using this machine.
Now, Josh, was this the first 3D printer that Mimaki developed?
This is the very first one, and it's really kind of interesting because with other printer companies, they came at full color 3D printing with a 3D background and then tried to figure out color. Whereas Mimaki had an extremely strong color background, and then we worked to learn 3D. So it's kind of 2 different directions. But yeah, it's, I think, somewhat interesting to have your very first 3D printer be a flagship industrial machine, but that's where we are. Yeah.
Fascinating.
So quick shout out to this artist, Maria Panfilova. This is a piece that she did in ZBrush that we printed out on the 3D UJ553. Just a really incredible artist and a really cool piece. But the more dry part of this is the specification. So just to break this down, the machine is printing with UV cured photopolymer resin. So it's liquid that's being turned to a solid. We jet those through 8 industrial inkjet heads. So there's 1 each for cyan, magenta, yellow, black, white, and clear, and then 2 heads for support. And it's good to note. I probably should have had a illustration of this. I apologize, but it's good to note that if you were to take this model and cut it in half, what you would see is you would see a mix of white and clear on the center, and then the outside edge would just have the color, right? So think of like an M&M where you've got the hard candy shell and then the chocolate on the middle. This is a similar idea. But the color that's on the outside is pigmented resin. So it's the same physical properties as what's building the structure. So we're not jetting white and then coloring it. We're actually jetting pigmented resin. So the outside color layer is just as strong as the inside, right? We have a very large build size, so up to 20 by 20 by 12 inches. And just as a little point of reference, the reason that we call this the 553 machine is 508 by 508 by 305 millimeters. That's where that comes from, right? So there's 4 print modes. There's a 22, 32, and 42 micron for the Z thickness, the layer thickness. And then we have 1 special print mode that's called color and clear that goes down to 19 microns, right? We cure the resin using UV LED lamps. So it's a cooler lamp, so you get less warping. We use a flattening roller, and then there's a dedicated PC with a touch screen that we use.
Okay. A couple quick questions on this one, Josh. When you say color and clear, can you actually print in like transparent colors, or what does that mean?
Yeah, so it's a really cool mode where you're basically taking a full color model like you see here, and then encasing the entire thing in clear, whether it was a sphere or a cube, or even just the actual shape of the model with just a thin layer of clear all the way around it. However the artist has designed it, but it's just a special print mode that prints a little bit thinner in order to maintain the so we don't get a lot of bleeding between the color section and the clear section. It's used a lot. We've got a couple artists. There's an artist, David Heron, which you'll see on Instagram, who does a lot with like surfers and waves, does some really cool things with this, with that print mode. And then we have a lot of medical applications that are using this as well for medical models.
Really interesting. And then the other thing is, when you say flattening roller, how does that apply to the technology? If you're just curing, colors layer by layer, where does the roller come in?
Yeah, there's a graphic for that a little bit later, but basically the idea is that when we're jetting down this resin, we're using one LED lamp to what they call pinning the material. So you're basically using the one lamp to hold the liquid in place and get it to a semi rigid format. And then the roller is literally that. It's a metal roller, like a rolling pin, that goes over that layer, and that's what maintains that layer thickness. And then as that returns, the final LED lamp cures it to a solid, and then we start the process again.
Okay.
Yeah. All right. So this is the world's first truly photorealistic full color printer. So we were able to print over 10 million unique colors, which this is 10 to 20 times more than our closest competitors. Again, printing with CMYK white and clear. And as I mentioned earlier, it's a pigmented liquid photopolymer resin, jetting it out, super accurate dot placement, drop placement. And that's how we're able to get the colors that we can.
Here, does it yellow?
So it is a photopolymer. So there is currently a little bit of a yellow tint to it. It doesn't tend to yellow much over time, but we have some exciting things coming up that we'll be able to talk about probably closer to the rapid TCT time, which will be mid-September. So stay tuned then and ask again about our clear.
And I have a quick question on this slide. Josh,
Yeah.
Is that actually 3D printed, that image right there?
Yeah, so this is one of our more famous images. This is a model by a photogrammetry studio out of the UK called 1024. And that's an actual photo of a man that's been turned to a 3D print, and that is printed directly on the Mimaki 3D UJ553. It's eerie how realistic it looks. And the reason that I like to use this picture is that a lot of times when you see sample 3D prints, they're always really bright, vibrant color. They're bright red and oranges and greens, which is great. But even if you have a very limited color palette, you can hit those colors. A lot of times where this 10 million colors comes in is things like this. It's subtle shading. It's the difference between going from the ruddy pink of his cheeks down to his start of a 5 o'clock shadow on his upper lip, right? I mean, those are the subtle things that if you have a limited palette, you cannot reproduce those, right? So it's a great sample, and we use it a lot. But he is, I think the adjective that we get most often when people hold that model in their hand is creepy. So.
Yeah, I mean, he doesn't look happy. Like I would say that, but
Yeah.
Again, the realistic coloring and everything else is just mind blowing. It's amazing to see what that machine could do.
Yeah, he's clearly a man who has seen some things, and we're really excited that we're able to reproduce that and be able to show that to people.
Josh, what size is the man printed in?
We've printed him in a whole bunch of different sizes. That particular one is it's a bust that is probably about 4 inches tall, but we've printed that face as a full size head. We've done smaller ones, all different sizes, right? And that's one of the really great things about having that large build area is you have the ability to not only print something really huge, which we'll show in a little bit, but also the ability to mass produce a bunch of things, so you can step them out in the XY direction, but you can also step them out in the Z direction and fill the entire bed and print a lot, right? All right. So another shout out to an artist here, Carlos Ortega, very talented artist. That piece is actually printed in 4 pieces. And we did this mostly just so we could easily pack it and ship it. So the base is separate, the body is all together, and then the 2 wings are separate as well. And Jaime Martinez just did an amazing job of notching out the back for the wings so that they just set in very cleanly, so it ships really well. This is again another ZBrush sculpt. But the point of this slide is really the fact that, again, Mimaki, we've got over 17 years of flatbed UV printer innovation. That's where this machine comes from, is from the flatbed UV printer world. So the same printers that people might use to print on USB drives or things like that, that same flatbed technology and UV curing is what's used in the 3D device. So in 2004, we came out with the world's first UV curable flatbed printer with white ink. 2010, the world's first UV LED curable benchtop inkjet printer. And then in 2017, the world's first full color 3D printer that can do over 10 million colors. So there's a nice lineage here for these machines.
Interesting. So essentially, you use the 2D technology to then just add a Z-axis into it and then kind of bring the color of Mimaki to 3D printing. Is that kind of what you're saying?
Exactly. If anybody on here has used flatbed UV printers before, you know that you can get texture and some textile feel just by printing layer on top of layer on top of layer. And what the Mimaki engineers looked at and said was, why do we need to stop at a couple millimeters? Why can't we just keep going? And then that ability to print just using the white and clear as that center and put the color on the outside edge, it just came together in a really fantastic way. Yeah.
Josh, can you mix clear and color?
You can. So within our software, well, two things. One is that the models themselves, the overall build volume is a mix of white and clear together. That's done for a couple different reasons. White ink is a more expensive ink in any inkjet technology because of the pigments that are used in it. So we use the white to be able to help with the reflectance in order to give the color some background. But we also use clear in order to help keep that cost down. But if you have a model that's, let's say you have an or a series of STLs that are broken out, so a model that has different parts to it, that some are separate STLs that come together. Within the software, you can assign one to be color, one to be clear, one to be white, one to be transparent, whatever it might be, and then have those print all at the same time. So it can print at the same time, color, clear, solid, all together.
This piece in particular looks very delicate. How durable are these parts?
Yeah, so that's a great question, and one that we get a lot. There are some numbers around the strength of it and things like that, but the reality is that this machine was designed really to be more of a prototyping type machine. However, we found that the parts are strong enough that we can use do things like this that would be considered not really toys, but collectibles. So the idea that you could handle this, you can pick it up, you can look at it, and then put it on the shelf is absolutely fine. You're not going to want to give it to your 5-year-old. If you were to drop that from any height on a hard surface, it will probably crack. Yeah. So it's got some properties similar to ABS, but yeah, and a lot of it depends on the object itself. For example, if I take a look at this guy, I'm not sure how well you can see that, but I can put a good bit of pressure on his legs and they're not going to break. But if I try to do the same thing on this sword, you can see it's got some flexibility to it, right? So you have to be conscious of that in the design. But yeah, you're not going to be printing functional tools or toys with this. But we do have multiple customers who are doing higher end collectibles. This is a great example of one here, right? And I think everybody knows about these folks, right? Hero Forge. So they're a big Shapeways partner, and so they're printing these little guys. There you go. Yeah, get them in there. And so nice small things. And again, they've got some durability to them, but if you really put your hand down on it, you will definitely crack it. But that's the great thing about the Shapeways offering, right? Is if you want to figure out what is the tensile strength, how is this going to work for my application, send your model to Shapeways, print a sample, and get it in your hands and see how it's going to feel and how it works for you. That's really the best way to do it.
We have one more question.
Yep.
Are the models post-processed, or do they come out of the printer looking just like this?
Excellent question. So in earlier slide, we talked about the fact that there is a support material. So we use a water-soluble support material, meaning that, can you guys see my cursor on the screen? No? Okay. All right.
So, really.
So if you look at this model that we're showing here, and let's say that we printed it exactly in that orientation, right? So you've got the 4 legs. We're jetting a liquid, right? And then we're turning that to a solid. So in order for us to get the belly of that beast or the knee there, right? There's a gap between the base and where that part of the model starts. The ink or the resin has to have something to land on so that we can cure it. So what we do is we print the water-soluble support material from the base up to where the model is going to start, and then we jet resin on top of that, cure it there. So it's one big solid piece, and then once the model comes out, we break away the support material, and then we'll soak it to dissolve the rest of it. Once that support material is all dissolved, what you see here is the final piece. So that piece, there's been no post coloring, there's been no painting, there's been no color touch up, there's no coating on it, there's no sprays, there's no nothing else. So when you say post processing, there is post processing to dissolve the support material, but nothing else. Now we do have some customers who have applications that they do want some kind of a post spray, whether they want it to be more glossy or more matte, or they need some kind of a protective coating on it for special applications. But in this case, that color that you see, that's the color you can expect coming out of a model from Shapeways.
Great. We have lots of great questions coming in, but we are going to go to a poll question because some of the questions the audience have asked are coming up in the presentation. Okay. So our question to everyone is, how many of you have printed in 3D printed in full color? Give everyone a few moments to answer this.
Wow.
Yeah, way more have printed than I thought it would have actually printed before. So that's exciting.
Yeah, it's interesting because, you know, as we go to trade shows and webinar or trade shows and things like that, and we're talking to customers, there seems to be an equal balance of people who have been exposed to color 3D printing since it was originally started back in the, believe it or not, the 80s, as people that have absolutely no idea that this can be done at all, right? So it's kind of not a surprise to see that mix. But you know, again, this is one of the things that really excites Mimaki about working with Shapeways is to make this more accessible and get it out to more people so that we can see that this poll, you know, when we come back and do some, hopefully some webinars with Jaime on the specifics of how to prepare files for color printing, that we see that the yes, I have the printed piece, we see that line go way up because people have been more exposed to Shapeways and to the Mimaki technology. Cool. Any other questions, or should I move on?
We do have a couple more questions.
Okay.
One is, this person saw an outdoor sign for their first example. What type of lifespan can you expect with that type of exposure? And then there's a follow-up question of, how does it handle heat and deformities from the heat?
So this is an excellent question, and I'm going to be a little bit candid on this one. So Mimaki, coming from a signage and graphics background, when they designed this machine, they had the idea that it was going to transform the signage market. And the reality is that what we're finding is that there's much more adoption in prototyping, in you know, gaming, in medical, those types of markets. And part of those reasons are that these materials do fine outside until you get to the weather extremes. So if you get really, really hot, which this summer seems to be everywhere in the United States, or you get very, very cold, when it's cold, things can get a little brittle. When it's hot, if you have thinner pieces, they can start to soften and get a bit deformed with the sun. So signage is something that I think you can definitely do with this machine. Outdoor signage is probably something that I would say you want to do some testing ahead of time and see how that's going to work for the environment that you have.
We can move on to the next slide.
Awesome. Okay, so speaking of prototyping and things like that, so who is this technology for? It's for people who the color gamut and the color accuracy is #1 on their list, right? There are 3D printers out there that have stronger materials, but there is no other 3D color or 3D printer out there that has the amount of color accuracy and the amount of color gamut that the Mimaki has, right? We're able to do fine detail, and unfortunately this slide doesn't show it as cleanly as you would see in person, but that shoe, which is right here, the amount of detail on this shoe, from the texture that you can see on the bottom to there's I'm not sure how well this is going to show, but the texture in the fabric area, things like that, that detail getting down to 22 microns and below really does an amazing job, right? So markets for this machine, obviously entertainment and gaming, which you've seen, collectible figures, which you've seen, medical models. We do have some major medical facilities in the United States that are using this technology right now. Visual prototyping, footwear, packaging, consumer goods, toys, and then there's some GIS mapping stuff that you're going to see in a little bit as well. So yeah, prototyping and limited production collectible type things, that I think is really kind of the sweet spot. We've been really pleasantly surprised at how the gaming industries have really kind of flocked to this machine and this technology. So I think Shapeways is going to see some really cool models coming through, and I'm excited to see what kind of things they can output with it.
Now, could this be used for jewelry?
Yeah, it absolutely could. I would say that when you're talking about jewelry, if you're thinking about like, let's say, a pendant or a brooch, absolutely. If you're talking about making a chain with it, you can definitely do it, but that's where, again, that tensile strength of the material might not be the best choice. But yeah, for doing jewelry, earrings, that sort of thing, absolutely.
The new 2207.
Oh.
And are we going to be talking about that?
So I will for this presentation, the 553 is really the main thing, because that is what Shapeways is currently using. I will address the 2207 real quickly, and then we'll slide through. The main things to know about the 2207 is same photopolymer resins, right? So the color that you get from the 553, you can get from the 2207. Much smaller build area, and it will be slower. If you have questions about the 2207, you're welcome to email me directly or contact me directly. And I will say that you will be seeing the 2207 printing live in the booth at the Rapid TCT show in mid-September in Chicago. All right.
Great. Thank you.
Okay. So printhead technology, I won't spend a huge amount of time on this, but just the fact that the printheads that we use are industrial inkjet heads, they're piezoelectric heads, and they're variable drop grayscale heads. And what that means is that we're able to jet droplets at multiple velocities in order to have them join in the air, which is like crazy science fiction stuff, in order to create larger drops to be able to get the different drop size that we want. Why is that important? Because in order to get full, deep color coverage, like these reds and black, and also be able to get really fine detail on a model. You've got to be able to have the big drops to get the deep rich color and the little bitty drops in order to get the detail, right? So how we do that is again a little bit of science fiction through this waveform control. And I'll just kind of breeze through this, but the basic idea here is that we're able to send an electrical signal very, very accurately that tells the piezoelectric crystal how to pulse and when to pulse in order to be able to jet out the droplet at the volume that we want, the shape that we want, and make sure that it lands in the place that we want in order to get the most accurate color. So it's one thing to be able to jet a whole bunch of ink, but it's another thing to have it land where you want, in the shape that you want, in the place that you want. Right?
So interesting. These guys are using electrified crystal to shoot color onto a surface.
That's what I'm saying. It's
mind-blowing.
Crazy stuff. All right, and then we talked about this a little bit earlier. So we use UV lamps because we're able to control each individual lamp to get the bulb to turn on where we want, when we want. So when we jet the ink down, on the image on the left-hand side, you see that the UV LED on the right is curing it just to get the ink held in place. And then when the carriage returns to the right-hand side, you can see the rollers coming down. It's uniform, or making a uniform layer. And then the UV LED lamp is curing it there as well, right? To get it to that solid. And then we repeat that process. Okay.
Okay, we have another poll question. This is our last poll question for the day. What height do you feel you can print a 3D piece in full color?
So I'm going to say this is a bit of a trick question because it doesn't say what is the maximum height.
I did, yes. I may have done that on purpose.
But yeah, in this particular machine, we can do 20 by 20 by 12 inches. So we can go up to 12 inches tall, which is crazy big. But we can also go down, as someone mentioned there, thank you for that, also small. We can go under 2 inches as noted by, right, these little guys. So really any size you need. And so let's take a look at some stuff that is big. So these are probably, as far as Mimaki USA, these are probably the two, or not probably, these are the two largest pieces that we have printed. So one on the left-hand side is actually a GIS map of a island, the island of Vorovoro, which is in the Fijian Islands, I believe. The story behind this one is that they're trying to figure out how to build a dam in order to make a freshwater reservoir in order to have fresh water for this particular island. So this one was almost the full bed size in the X and Y axis, and then it's 6 inches tall. We printed this in what we call standard print mode, which is 32 microns, and it took us 93 hours. So I think that really speaks to the quality of the Mimaki machines. That's 93 hours, unmanned, started on Friday, come back after the weekend, and that's totally done. And that if you flip it over, it's mostly solid. There's a bit of a honeycomb that Jaime did on the bottom of it in order to save some weight, but that's a really, really cool piece. So the other one, which has to be my favorite thing that we've ever printed, was the Nemesis model by an artist called Dope Pope, who he does these like contract Godzilla models and things like that. He's an amazing guy. So that piece is 18 inches tall. It was printed in two pieces where the tail section where it attached to the body actually comes off. And what we did, and this speaks to one of the comments earlier about being able to print color and clear and things like that. Jaime hollowed out that entire model in ZBrush, I think it was, or Blender, I don't remember. And then the yellow ovals that you see on Nemesis on its neck are actually tinted clear. So it's clear with a bit of yellow and magenta. And then we put LEDs in a battery pack inside of the model and then attached the tail so that it would actually glow from the inside. But that was 158 hours of printing because that one literally, I think we printed him kind of face down and then the tail separate. So he took up a lot of the Z-axis height. But again, it printed for a week and turned out perfect. And we took that to one of the ZBrush shows and it was a huge hit. So some really great examples of things that you'll be able to do with the machine at Shapeways. Basically, you know, if it fits in the build chamber, you can print it. All right, so another thing, which this is a little bit on the technical side, but the Mimaki machine is one of the few out there that has a true ICC color workflow. I shouldn't say it's the only one that has a true ICC color workflow, but it has a customizable ICC workflow. So Shapeways, let's say, you know, with multiple machines, oftentimes a customer will create custom ICC profiles. That is a file that describes the output condition of the machine under a particular environment in order to ensure that if you have multiples of these machines, that each one prints the same. So you get consistent color across them, right? Another amazing model by Martin Verhoeven. This was one that we did a while back, and unfortunately, it took us a while to get this to him because of the pandemic. We had some craziness, but that's finally in his hands, and that's just an amazing gremlin model. That one is about, I think that one's probably about 8 inches tall, but that was printed on its back, and again, he comes off of the base and then lays down, so it was printed in 2 pieces. So for the designers in the group, we can work with vertex color. So meaning that if you have an object that's built of multiple polygons, you can assign a color to each individual polygon. We can also work with UV mapping, which is what you see on the right-hand side. You have a 2D image projected or wrapped onto a 3D model as a texture. That seems to be kind of the best workflow because it allows you to have a high resolution texture with a lower polygon count. Whereas if you use vertex color and you do low polygon count, you're going to affect how the color looks, right? So we support STL, OBJ, PLY, WRL, and 3MS files. I'm not sure, I guess I should have asked this earlier, on the Shapeways side, if they're going to be accepting all of those formats. I would assume STL and OBJ for sure, maybe 3MF. PLY and WRL are not used all that often in our workflow. And then you'll see in a minute that there are some options if you use STL where you can assign color within the software. If you're using the wrap texture, OBJ or 3MF are the best choices, where OBJ seems to be kind of our personal favorite in-house. Any questions? Move on.
We're good so far.
Okay. All right. So yeah. So if you have original STL data, so in this case, me being the amazing 3D designer that I am, I made a cube and I colored it red. That's about the extent of my design abilities. So if that's the original STL data within the software, you can assign a color, any color you want to it. You can have it just be white, which is the kind of raw core material. You can make it be clear, which is just the clear ink, or you can do what's called skeleton color, meaning that you can have clear, but you can assign whatever tint on top of it that you want, right? Again, we've got an artist that does these surfing wave things, and so he'll have the water, and it will be a clear print, but there's assigned an aqua color in order for the water to look like water. And then with STLs, you can nest objects inside of other objects and assign color to them separately, and then end up with an assembly that is, say, an opaque object inside of a transparent object. Those things can all be done. So let's talk a little bit about full color. This is one of those things that this is a little kind of near and dear to my heart. In the marketplace, we hear the term full color 3D printing thrown around a lot. We hear full color, we hear full spectrum, we hear photorealistic, and there's different technologies in full color or in color 3D printing that have these different gamuts or limitations, right? So what I think is important is when you look at the image on the left-hand side, so that's a representation of a fairly full gamut at 16 million colors. And you can see that the gradation between colors is very clean. It's very smooth. There's not a lot of separation between colors. And that when you look at that smooth color gradation, you can see that it's nice and even and smooth, right? When you take that same image and you drop it from being built with 16 million colors down to 1,000 colors, you can really see that the steps between colors becomes very, very noticeable. And within the gradient, it becomes posterized, and you've got, you know, delineation between each individual step. So we have, this is kind of our point of pride with the 3D UJ553, is the fact that we can do 10 million colors. Again, there are other materials, there are other machines out there that also do a lot of colors, but not nearly as many as the Mimaki can do.
So Josh, if you're like trying to match a Pantone, obviously you're not going to nail it with Mimaki, but compared to all the other competitors in the market, you're going to get the closest.
Yeah, that's absolutely true. I wouldn't say that we're not going to nail it. There are definitely Pantone colors that are well within the gamut of the machine, but there are certainly Pantone colors that are outside of any traditional CMYK printing device, which whether you're talking about Mimaki or 3D Systems or Stratasys or HP, they're all CMYK output devices, right? The best way that I can think of it is Pantone is something like 1,076 specific colors that are all defined, right? And if you're in the printing world and you want a specific Pantone color, whether it's Pantone 186 or whatever it might be, you're literally going to have a can of ink that is that color, right? So the analogy that I really like is the idea that if Pantone has 1,000 colors, it's like having 1,000 crayons, right? Like you got the box, you went to the store, and when it was time to buy school supplies and you wanted the big box of crayons, had the sharpener on the front and all that, right? So you're trying to match one of these 1,070 crayons, right? Well, the printer, if you think of that as a box of crayons as well, where some of the other machines, they've only got 500 crayons or 1,000,000 crayons. We have 10 million crayons, right? So our ability to, or the percentage chance that you're going to be able to match one of those 1,000 colors is much better if you're working with a box of 10 million crayons than if you're working with a box of 500 crayons, right? So yeah, I think we definitely have the edge when it comes to being able to most closely hit color, whether you're talking about a Pantone color or you're talking about a logo specific signature color for a company. The Mimaki is going to have your best opportunity to do that.
We have a question about gradient, but I think that is in your next couple of slides. So okay. I'll let you talk about it and see if it answers the question.
Perfect. Yeah, so we'll get to the gradient thing in just a minute, but this is one other thing I wanted to mention. So there's the number of colors that the printer can output, but then there's also how many colors does the color system allow you to request. And one of the things that Mimaki does that the other 3D color printer manufacturers don't do is that we also support the Adobe RGB 1998 color space as well as sRGB. So you can see from the graphic there, Adobe RGB 1998, which was really developed for CMYK printers, or to better encompass the gamuts of CMYK printers, is more extended than the sRGB gamut, specifically in the greens and blues and cyan areas, right? So you're able to request more color, and if you pair up the ability to ask for more color with an output device that can deliver more color, then you end up with more accurate, better color, period. Right, so let's see an example of that. So this is two images here, one on the left, one on the right. And this is the Mimaki 3D UJ553 versus the HP Jet Fusion 580. And the Jet Fusion 580, which is a very popular 3D printer. I don't know if Shapeways has one of those. I think maybe they do, not sure. Nope, don't have one, never mind. But it's a powder-based printer. So it's fusing a powder in order to create a solid, and they do have the Jet Fusion 580 is their full color version of it. Now, on the plus side for the Jet Fusion 580 is that their material is stronger. So you've got a lot more tensile strength on the Jet Fusion 580 than you have with the Mimaki. But on the Mimaki side, if you take a look at the image on the left, you can see the Jet Fusion 580 print is on the bottom, and the Mimaki 3D UJ 553 print is on the top. The first thing you'll notice is that the texture difference between the two, right? The powder-based print is a much rougher feel coming right off of the printer, whereas the Mimaki print, it's a plastic print because of the photopolymer, so it's a much smoother print. But what's more striking than that is when you look at the color difference, going from red to orange to yellow to green, on the HP print, you can see it's a very abrupt change, especially from the orange to yellow and from the yellow to the lime green, let's say. It steps very harshly. Whereas if you look at the Mimaki print on top, it's a much cleaner, smoother gradient, right? So that's really where you're going to see a lot of the difference. Even more striking than that is if you look at the image on the right-hand side, you can see that the Mimaki print, we go from a green to a cyan to a deep violet, really, color. Again, a nice smooth transition, but we're able to go through all those colors. When you look at the same print from the HP machine on the left-hand side, not only is the gradient more abrupt, but the gradient actually stops because they can't get anywhere close to that deep, rich indigo color. It just isn't within their color gamut at all. So I think these are two really good real-world examples of where the color gamut on the Mimaki machine is so valuable. And again, as we talked about earlier, the Mimaki machine is really designed for people where color is the primary concern. In this case, if you needed that particular little fixture to then withstand a bunch of force, but color wasn't that critical, maybe the Mimaki machine isn't the one for you. But if you say, look, this color is representing where stress points are within this particular model, on the right-hand side, if that indigo is showing a particular level of stress, you can see that in the Mimaki machine or the Mimaki model, but you cannot see it at all in the HP model. Does that answer the gradient question?
It answered part of it, but the other part is, can you do a smooth transition from opaque to transparent?
Can you do a smooth transition from opaque to transparent? Sort of. Okay, so there's two parts to this answer. One is we could make it look like that, but there's going to be an area where you're going from opaque to transparent, which is going to be a pretty clean break, but you could have a color transition on top of that. The second part of it is that the way to do what I believe you're asking to do is to do it through voxel-based color. The Mimaki machine absolutely supports voxel-based color. The question is, does the workflow feeding the machine support voxel-based color, right? So straight out of the box, the Mimaki software does not do that. I'm not sure about the Shapeways side of it, but there's some other things. There's some limitations in using voxel-based color or voxel-based printing, period, which is more file format based. It's pretty awkward to do, but there's some things happening with file formats, and specifically, well, I don't know if I'm supposed to talk about that, but around some of the file formats that in the coming months we're going to see has better support for voxel, better support for transparency, and better support for color. So can the machine do it? Absolutely. Can the software feeding the machine do it? It's a little tricky right now, but we're going to see in the hopefully pretty near future that's going to become a whole lot easier.
Do the colors fade over time?
I would say it depends. In general, I would say not really. I've got samples in my office here that have been around for many years in an office environment that show no sign of fading whatsoever. If though you took one of these models and you put it into a south-facing window and you left it there over time with direct sunlight, yeah, you would see some fading, right? Because again, we're working with photopolymers and they are going to be affected by it. But I would say I'm confident in saying that these models are very steadfast in their color in a typical environment.
Great, thank you.
Yep. All right, so we have just a couple more slides. I think I'm going to let Steve talk about this one.
Forge has been a customer of Shapeways for many, many years, and really started just from an idea of two guys who came together and wanted to, bring some of the gaming ideas they had from fully customizing their characters to life. And traditionally in the tabletop space, it's you print out your character and you paint it. Well, what if you don't want to paint it? Or what if you're not good at painting? For instance, exactly like me. Then all of a sudden you want to make that investment. You want to. And in all reality, the technology wasn't here. Like, we had tried other full color options. We had really, really done it. And until Mimaki came along, we really weren't able to get to the fine level of detail, on the micron level, and kind of what Josh's been talking about from the color perspective. If you just look at some of these characters here, you can see, even the slight shading really helps define the face and the smaller features and characteristics of these characters. So I would think without Mimaki, we would never have been able to truly release a full color option for Hero Forge that would meet the requirements of the player and then bring their gaming experience to life and really make them feel kind of endeared to the character that they're able to customize on the Hero Forge site. So it's been pretty amazing to see where the technology has come just even over the past couple of years and where we've gotten it to. So.
Can I also add that if you've never tried the Hero Forge customizer, it is basically a video game in of itself. You can waste an amazing amount of time customizing your character because the number of options in there are insane, and they keep adding more and more options to it, which is really, really cool. So yeah, definitely check that out. It's an amazing thing.
Yeah, weekly on Tuesdays are always new features. And one cool thing too is you go in, you create a profile, they'll actually save your feature set. So you can go back and play with it later if you run out of time.
Very cool.
In the handouts section, we have 3 handouts that everyone can download. It is the case study for Hero Forge, a case study for Mimaki, and a one sheet about Mimaki capabilities.
Awesome. Thank you. All right, just a couple more slides. So this is another one that's near and dear to my heart. So we were contacted by a gentleman named Olaf Dijel out of the University of Auckland in New Zealand, and he has a side business designing or making making guitars through additive manufacturing, and his company is called Odd Guitars. And so he contacted us and said, hey, I've got this idea for a full color 3D printed guitar. Would you guys be interested? And we said, absolutely. So this guitar that you see, the body is fully 3D printed in the Mimaki 3D UJ553. The neck is a traditional neck. There is a block of wood that's in the back of the guitar that the neck is attached to. But this is a fully functional guitar. It sounds amazing. The image on the left-hand side is actually a Mimaki regional manager for Toronto. His name is Lucas Crossley, and he has a YouTube channel, Lucas Crossley Guitar. So if you go on YouTube, you can see and hear this guitar being played, and there is an interview there between Lucas, me, and Olaf Dijel, the designer of the guitar, and you can learn all about what he does and how he did it. And we're really proud to say that after this, he was so excited about it that the University of Auckland bought a Mimaki 3D UJ553. So that was a really cool example of what can be done. So that body of the guitar, the entire thing was printed all in one piece. Again, just came off the bed, dissolved away the support material, and then we shipped it to New Zealand, and Olaf put the guitar together. Really cool stuff. And I think for me, that is all I have. So certainly open to any questions, either from the Shapeways folks or from anybody that is attending.
We do have a question about flexible inks and materials, and is that going to be in the future of Mimaki?
That is a question that we get a lot, and I would say it is in the future. I can't tell you the timeline for that. That is probably one of the most requested things from Mimaki, and certainly something that we know that our competitors have. We've been really focused on the color part of it, and as I hinted to earlier, the clear part of our materials, but flexible is something that we are aware of, and I can't really say more than that at the moment.
Okay, with that, we do have other questions that I think are going to take us longer than 4 minutes to answer. So we will follow up with each person who we didn't get to your questions to answer. And I will turn it over to Steve to wrap up our presentation today.
I mean, the question, interaction, everything else was really fun to see. Fun to see the excitement. I personally love this technology, and I think we're almost on the precipice to see. And I think almost we're waiting for the design to catch up with the actual abilities of the machine. So I'm really excited to kind of see where this will take us. Thanks again, Josh, for coming in here talking about it. And then anybody who in the audience does want to have additional questions, wants to follow up, please reach out to the Shapeways team over the website or your dedicated account manager, and we will absolutely help you out from a design perspective, printing perspective. You know, we're here to do anything in regards to full color 3D printing. And thank you so much.
Steve, you bring up a great point about design for 3D color, and Mimaki and Shapeways is going to be doing another webinar in October. We are finalizing the dates for a design webinar specifically for full color. We will definitely email everyone who registered for this webinar to attend that one once that date is solidified.
That's exactly what I was going to mention. Yeah, we're really excited about that. As I mentioned, our application specialist or 3D application specialist, Jaime Martinez, who you may have seen around the web. He has some really great tips and tricks on designing for full color 3D, whether you're a ZBrush person or you're a Blender person or you're a Adobe Substance person. He's got a lot of great knowledge, and we're super excited to get with the Shapeways team and share that. So yeah, we look forward to seeing everybody in October. That's all I've got.
Thank you so much, Josh and Steve, for your great insight, and we hope everyone has a great rest of their week.
Thanks, everybody.
Thank you, everybody.